Good morning, everyone. How are you guys doing today? Good. How was your PL chill today? Good. What did you do today? Review? Review the exam or went over the exam? Which one? Did you review for exam 5 or went over exam 4? No. Oh, exam 5. Good. So reminder, our next exam, exam 5, is exactly 1 week from today. And it will be a combination of chapter 10 and 11. So if you haven't noticed, I posted the review sheet long time ago on Brightspace. Study the review sheet very well. Do similar questions in the homework. What you have on the review sheet, you'll be fine. And this exam will be long, 1.5 hours. Our final exam will be 2 hours, 30 questions. So for 1.5 hours, 20 questions is a fair amount. So expect to see around 18 to 20 questions in this exam. Question, comments, concern? Nothing? Okay, so yesterday we talked about chapter 11. The last thing we talked about was graphs of quadratic function. And we said quadratic function, they have two formats. One is standard form, the other is general form. We like standard form because in standard form, we see our vertex, which is very important. Vertex tells us whether we have a maximum or minimum in our function. And we care about maximum minimum because we face many scenarios where maximum and minimum is the only thing we care. For example, we want to get maximum amount of profit when you sell something, or we want to spend minimum amount of money when you buy something. So in this format, we have h and k. So inside our function, we have x minus h. So when you find the vertex, we take the opposite of h, the opposite sign. So the negative sign becomes positive. So if your formula has a positive h, that means when you look for the vertex, it should be negative h. And k takes its sign. So no problem with the sign of the k. Axis of symmetry means the vertical line which splits a parabola into two equal pieces. And since it's a vertical line, its equation has to have an x equals something. So we have x equals the x below the vertex. Then we have general form. General form is useful if it's factorable, your equation, or you're looking for y-intercept. If it's not factorable, we don't like it because if it's not factorable, either you have to use quadratic formula to solve for x or complete the square. And since in this format we do not see our vertex, so we have to use a formula to find out vertex. So in general form, the vertex, x below the vertex is negative b over 2a. We have a formula for the x value. Unfortunately, we do not have a formula for the y value. So once you get the x value by replacing a and b, we replace that into the function to get the y value, and we get the vertex. Then we talked about shape. If our x squared term is positive, we have upward parabola. If our x squared term is negative, we have downward parabola, upside down. In upward parabola, we get minimum, and in upside down parabola, we get maximum. Domain, since parabola is a polynomial, so domain is everything. It means we can replace any number with x. There is no restriction on the x. On the other hand, our range depends on the vertex. If you have an upward parabola, the range is the y below the vertex till infinity. But if you have an upside down parabola, our range is from negative infinity to the highest point y below the vertex. And then we stopped here. And we talk a little bit about finding x-intercept. Finding x-intercept, it means same as solve for x, find the zeros, find the root. All four things means the same thing, solve for x. So to solve for x, to find the x-intercept, we set the y to be 0 and we solve for x. And then depending on which type of format is given to us, we use different methods. If the general form is given, then if it's factorable, we factor solve for x or like it's easy. If it's not factorable, then either use the quadratic formula or you can use complete the square method. Use quadratic formula. I should write one more line. Either quadratic formula or complete the square. And then if the standard form is given, we set the y to be 0 and we get this x alone. So we get rid of k, a squared, and h, one by one. And we get the x alone. To find the y-intercept, there's only one method. Set x to be 0, wherever you see x, all the x to be 0, and you get the y alone. Solve for y. Question? Now, what will be in the final exam is something like this. They either will give you the standard form or general form, and they will ask you to graph it by finding x-intercept, y-intercept, and vertex. So you have to find 3 things and then graph, so total 4 things. Now, in this format, do you see the vertex directly? No. So when you don't see the vertex, we have to find the vertex using a formula. So let's start with the vertex. Vertex is a point. So it has an x value and a y value. We need to find both of them. The x value of the vertex is same as, it has another special symbol h. And the formula is negative b over 2a. So in this equation, what is our b? Negative 4. So it's negative 4 and divide by 2 times, oh, I forgot a. What is our a here? No, x is the number, 1. So we have positive 4 over 2, which is 2. So the x value here is 2. Now there is no formula for y. So what we do is to find the y, which has a special symbol k, is substituting x into the function and then you get the y. So x squared minus 4x minus 5. Instead of x, we write 2 because we just found our x value of the vertex is 2. So we get 4 minus 8 minus 5. And what do you have from there? 4 minus 8 is negative 4. Negative 4 minus 5 is negative 9. So the y value of the vertex is negative 9. Sometimes they ask for axis of symmetry. So if that's for axis of symmetry, axis of symmetry is a vertical line, so it has to have equation x equals something. So our formula is x equals the x value of the vertex. which is h. So in our case, it will be x equals 2. Questions so far? So you're happy about our vertex. Now let's go to find the intercepts. Y-intercept is easy, so let's find the y-intercept first. To find the y-intercept, we set x equals and we solve for y. So equation is y equals x squared minus 4x minus 5. When you set it x 0, this becomes 0, this becomes 0. So we get y equals negative 5. But usually they like to see the intercept as a point format. So how do you get y-intercept as a point format? Y 1 over point. It means you need an x value and a y value. So you have your y value negative 5. 0. See, we set x to be 0. So x value is 0 and y value is negative 5. So if they ask for the point, you have to give them the point. Otherwise, you're going to use points. And if they don't ask for point, y equals negative 5 is fine. And now let's go find the x-intercept. Since this is, it doesn't matter which format is it. To find the x-intercept, we always set y equals 0 and we solve for x. So since we have y equals this function, that means we have 0 equals x squared minus 4x minus 5. So basically you're solving for x. Anytime you're trying to solve for x, your first step always should be what? Which method you always want to look at? Factoring. Is it factorable? Which two numbers multiply to negative 5 combine to negative 4? Negative 4 and? Wait, 4 times 1 will not going to give you 5. Multiply to 5. It has to be negative 5. Negative 5 and positive 1. What is our variable? X. So x minus 5, 0 gives us x is 5. X plus 1, 0 gives us x is negative 1. But again, they prefer points. So how do you write x equals 5 as a point format? Five, 0 and negative 1, 0. So we found x-intercept, y-intercept, vertex. And the last thing they are asking us to do is graph it. So when you graph, we just replace all the information we found in the plane. So we found vertex is 2, negative 9. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, negative 9 is here. And then we have x-intercept 5 and 1. So 1 is here. And then we have 2, 3, 4, 5. 5 is here. X equals 1, x equals 5. And our y-intercept is I did something wrong, right? -1. Oh man. -1 and +5. And our y is -5. So 1, 2, 3, 4, 5 here. Y is -5. X is -1 and +5. And vertex is 2, -9. So all you have to do now is connect all the dots with the parabola shape. So we got this, and we got that, and we have our parabola. It's not perfect, but we have the shape parabola. Any question? Say that. Here? Here? Vertex is 2, -9. X value is 2 and y value is -9. No question from anyone? Okay, then you try one by yourself. Do all the things we just did. Find the vertex, find the x-intercept, y-intercept, axis of symmetry, and then graph it. The axis of symmetry here is this line. So in my method, when you do them, they want you to draw the axis of symmetry. It's 5-2. Eliza still not here. Fabricio is here. Sergio here. Miley here. Oliver here. Himadri here. Mustafa here. Jacqueline here. Jiain here. Anaya here. Atsiri here. Sitlali here. Saida here. Mohammed not here. Ronaldo here. Daniel here. Jeremiah here. Camila here. Julia here. So 1, 2. 2 is missing. Oh man. Who needs help? Let me know if you need help. So Eliza, you missed this question. You missed this question. So copy it down and then you're going to do the next one by yourself. So when you divide, let me say it's more negative. So it is the ground, it will change your sign. And then so what must be negative one? If you divide by negative one, that means you're solving a problem. The problem was negative here. Even if you factor, still you have to divide it. So you factor, now you step to the left to divide the other negative one. So there will be no you can divide or you can multiply. We're dividing both sides from negative one. Negative one from top to negative one dividing. So if you do it here, this negative turns into positive. This negative, this positive turns into negative. This negative, this negative turns into positive. Yes. And then you have to are you this is negative extra. This is extra. And x is equal to this three. It's negative 3 squared is negative. Four constraint things.
Not 3 and 1. Negative.
Let's see the logical right. It is positive, but look, x square is going to get inside outside. What opportunity? Yes. We can say that's the key.
I want to change the. Negative vertex is good.
Yes, very good.
Everything is on the public here.
So is
So I think here is
but it is solved, right? So first solve this. Okay, well, you solve this. How do you start with 8? The symmetry, you have to build everything upon the original one, not the converted one. So you have to find the vertex from here, and that's intercept from there, and the line everything from here. When you find that intercept, then you can multiply both again. So you line is there. So you multiply it with the negative time. Always for everything. Not for anything else. Why is -1? You have 3 and 2, 1. That's 17. That's
all.
we replace the x into the original function. Because there is no formula for the y. Oh, this is the original function. Okay, let's do it together. Starting with vertex. Vertex is a point, so we're going to have x and y. So unfortunately, there is no, we don't see any, we don't see the vertex directly. So we have to use the formula, negative b over 2a. Our negative b means -6, a means -1, so we get -6 over -2. That gives us 3. So this x is 3. Now to find the y value, since there is no formula, we replace everything into the original function to get the y value. So negative and then 3 squared, 6 times 3. We get this negative is extra because it's outside of the parentheses. 3 squared gives us 9. We have 18 here and -8 here. Now 18 minus 9 is 9. 9 minus 8 is 1. So we have our y value 1. So the y value in the vertex is 1. That's how we get the vertex. Now axis of symmetry is the x value of the vertex. So x equals 3. It means the line which divides a parabola into 2 equal pieces is the x equals 3 line. Let's find the y-intercept next because it's easier. To find the y-intercept, we said x equals 0 and we solve for y. So equation is y equals -x squared plus 6x minus 8. Point x is 0, this is 0, this is 0. So we get y equals negative negative 8, but as a point format, it's 0, negative 8. Now to find the x-intercept, we set y to be 0. And we solve for x. So y0 means here we have 0 equals negative x squared plus 6x minus 8. But then we have a problem. Our x squared in order to factor, it has to be positive. Since we have a negative, so either it can divide or multiply both sides by negative 1. It will change all the signs we have. So negative x squared turns into positive x squared. Positive 6x turns into negative 6x. Negative 8 turns into positive 8. And now we're happy because we have a positive x squared. So which two numbers multiply to 8 combine to 6? Negative 4, negative 2. So we have x minus 4 equals 0. That gives us x equals 4. And then we have x minus 2, 0. That gives us x is 2. As a point format, we have 4, 0 and 2, 0. So we have all the information we need, and them. Let's start with vertex. Vertex is 3, 1. So 1, 2, 3, and 1. 3, 1. Our x-intercept is 4 and 2. So 2 is here and 4 is here. 2 and 4. Y-intercept is negative 8. Let's say this is negative 8 somewhere. So if you connect all of these, we get a parabola like this. And axis of symmetry means this line, x equals 3. So in my MATLAB, they want you to draw the axis of symmetry and then give them the equation for that. But if you don't see they're asking for axis of symmetry, you don't have to draw that. Question. And definitely there will be one of these questions in the final exam. So make sure you know it very well. Plus, there will be one question in the in-class exam. And now we have one question in standard form. One good thing about the standard form is that we can see our vertex. So the general standard form is y equals a x minus h squared plus k. This is the general form. So that should say general. This is the standard form. Now, if you compare these two forms, we can see that our a is 1/2, negative 1/2. And we can see, No. We can see that negative h gives us 2. But we're not looking for negative h, we're looking for positive h. So what is h? Negative 2. And from here, if you compare these two, we see that our K is -1. So vertex is HK. H is the X value and K is the Y value. So you already see everything here. H is -2, Y is -1. So vertex is -2, -1. We didn't have to do any math. We simply compared and got the answer from here. That's why we like the standard form, because we're not doing any math. You can see our vertex. When you see the vertex, we can see its position. So we can easily visualize our parabola. Now, standard form is not good to find the X and Y intercept. Okay? Because we have to do lots of work. So let's start by y-intercept. Just like before, to find the y-intercept, we set x to be 0 and we solve for y. So we get y equals -1/2 x plus 2 square minus 1. Now when x is 0, this get vanished. So we have y equals -1/2 2 square minus 1. 2 square, how much is 2 square? 4 minus 1. So we have half of 4. What is half of 4? 2. Minus 2 minus 1 gives us -3. So this is the x-intercept. In the point format, it's 0, -3. So see, previously we found that y-intercept in one line, but now we have to solve it and then get the y-intercept. To find the x-intercept, you have to do the same work. To find the x-intercept, we said y to be 0, and we solve for x. So y0 means we have 0 on one side, and then we have -1/2 x plus 2 squared minus 1. Solve for x means we want this x to be alone. So we add 1 on both sides. We get 1 equals -1/2 x plus 2 squared. And then we get it at the -1/2. To get to the -1/2, you divide both sides by -1/2. But dividing by -1/2 means multiplying by what? 2. So we multiply both sides by -2. So -2 and +2, -2 and -2 on the denominator cancel out. We get -2 equals x plus 2 squared. And now we have inside a 2, outside a 2. We take the square root. Oh man! And this becomes what? Square root of -2, is it real or unreal? So do you have to solve it? Can x-intercept be imaginary? So we just wasted our time. No x-intercepts. We don't even have to bother solving the right side. As soon as you see when something is wrong with my plan, it becomes imaginary. There is no x-intercept. So we have a parabola. Is it upward or upside down? Upside down, because our area is negative. So we have an upside down parabola. So do you have a space? No. Let me draw here. Our vertex is -2, -1. So let me draw -2, -1. And then our y-intercept is -3 here. We don't have any x-intercept. So our parabola is lying strictly below the x-axis. That's why we don't have any x-intercept. It's going to be crossing the x-axis. Good news, in the final, they usually don't give this format. They prefer the other format, the general format of a standard format. So most likely you will have question like this in the final. And these are in MyMathLab. So you'll see this in the homework and my on quiz on MyMathLab. Question? Okay, now you're going to do transformation. So transformation means, see here, we draw our graph based on vertex, x and y intercepts. Transformation means don't find everything, x and y intercept, vertex and everything, without even finding them. How can you graph your parabola? Well, we can use transformation. We relate how we are transforming from the original graph. So the original parabola always lies at the vertex. Either you have this if it's positive x squared, or you have this if it's negative x squared. Transformation means compared to the original shape, how you are moving your graph, how you are moving your shape. So in this class, we are going to learn 3 types of transformation. One is reflection, and you already learned reflection. Reflection means if you have a negative sign in front of your parabola, in front of your function, then it reflects about x-axis. So if it's positive, it's upward. If it's negative, it's downward. So anytime you have a negative x squared, it reflects about x-axis. Okay, second type of transformation is particle. Particle means either you're moving upward or downward. So if you have your x squared and then some number added, it means you are shifting 2 units up from the original shape. And if you have your x squared and then you're subtracting some number, it means you're moving your parabola 2 units down. So if you have your x squared, if you see your square and then a number, if it's addition, it goes up. If it's subtraction, it goes down. This is vertical movement, vertical shifting. The horizontal shifting, it means either you're moving left or right. And horizontal shifting goes inside your square term. Inside the square, if you have a number positive, you go other direction. So positive means you're supposed to go on the right side, but actually you don't. You go on the left side. And inside your square, if you have a minus sign, we're supposed to go left, but you don't, you go on the right. So the horizontal shifting is the weird one. It doesn't listen to direction. The vertical shifting listens to direction. Plus means up, minus means down. Horizontal, plus means left, and minus means right. So horizontal shifting is inside your square. Vertical shifting is outside of your square. That's it. Question? Let's do some example. Let's start with the original one. Y equals x squared. So y equals x squared is here. And now this x squared, you are moving which direction? You see your square and then plus 2. So which direction is supposed to go? Up, down, or left, right? Up. After you square, anything is up, down. So we are moving 2 units up. What does that mean? It means if this is your original x squared, you are moving your vertex 1 unit, 2 units up, and you are drawing a parabola again. So this is x squared plus 2. Compared to the original one, you are shifting 2 units up. And then here you have x plus 2 inside your parentheses. So inside means which direction you go, left, right, or up, down. It should be left, right. But for left, right, we go opposite direction. Plus, we're supposed to go right. But do we go to the right? We go left. Left 2 units. So what does that mean? If this is your original one, you're taking your vertex and moving 1, 2 units left, and you're drawing the same parabola again. So it's x plus 2 with a square. The original vertex shifted 2 units to the left. Why? Because we have plus 2 inside our parentheses, inside the square. And here, the original one shifted 2 units up because we have the original one and then plus 2. Take a look at this one. Negative x squared means which type of parabola? Upside down. Okay. And then here we have negative 2 after your x squared. So which direction we go? Down. Perfect. We go down 2. So this is the original one, x squared. We are moving our vertex 1 down, 2 down here, and we are drawing the same parabola. So x squared minus 2. So here the original one was x squared. Because of the negative sign, it turns into upside down. So negative x squared. For the second one, we see the original graph and then move it down to the original one, moving 2 units down. And lastly, we have minus 2 inside your parentheses. So which direction? Right. Inside means go to the opposite direction on the left, right side. So negative 2 should be on the negative on the left, but we don't. We go on the right. Right. So if this is the original one here, we are taking our vertex and moving 1, 2 here, and we are drawing the new one. So x minus 2 square. So these are left, right, these are up, down, and this is our reflection. In other words, yes, you have to remember your direction. X square and then a number means up, down with the correct sign. Plus means up, minus means down. But if you have inside the parentheses a number, it means left, right in the opposite direction. Now, what if we have all 3 things together? Then what do we do? So negative in the front. What does it tell us? Upside down. Then we have -4 inside the parentheses. Right. 4. And then we have +2 after you square. Up to. So we are doing all three transformations at the same time. This is right. Let me start. So the original one is this one at the vertex. Doesn't work anymore. Come on. So this is the original one, x squared, without any transformation. And we are shifting this. First, we are making it upside down. And then that upside down parabola, we are moving right. So 1 right, 2 right, 3 right, 4 right. And from there, we are going 2 units up. So 1 unit up, 2 unit up, we end up between here. So we draw an upside down parabola here. And my x-intercept, they are not scaled, but it doesn't matter because it says use transformation. It didn't say draw perfectly. So for transformation, it doesn't have to be scaled. The main thing is vertex. Where you are moving your vertex. So what's the position of the vertex? At the beginning, it was 0, 0. But right now, what's the position of this vertex? How many x and how many y? 4. 4 right, 2 up. So this position is 4, 2. And see here, we did the opposite of the inside, same as outside. So 4 and 2, that's our vertex. We always have to draw the original one. And in the exam, for the original one, 1 point, and for the transformation, 3 points. And then for the vertex, 1 point. So total 5 points question, this one. So this is y equals negative x minus 4 squared plus 2. Any question? Try the next one. And then we have 2 more. Try the next 3 by yourself or with your neighbors. So pass it to the original one here, and then it becomes upside down. So what we want to, I want to take it to the Oh. And then maybe vertex. From here, if I look into the graph, so first mention what the negative sort of consequence and other multiple terms and mention that's in area in here, negative is upside down, and inside is outside is there. So write this down and then down. We don't need to do any maths. Oh, we're supposed to. Okay. You always start from reflection. So this is original one to reflect first. And as a reflection, you move this and that. Wrong, right? Moving with the it's fast, really rapid. So from the original one, plus is supposed to go right. Do you go right? The left right doesn't listen to us. The left right is always upward. It's supposed to go right forward, but it don't. Up how many? Up forward. Plus supposed to go right. But you don't listen. I mean, that means they don't listen. One's supposed to go right and doesn't. So left, right, and listen. Up, down, and listen. Oh, this one. So you drew the last one, right? And so let's see what do we have next. Other way around. Okay, no problem. So negative in the front means upside down. Plus 4 inside the parentheses. We're supposed to go right, but we don't. We go left. And minus 2, down 2. So left. That means let me draw a little bit to the right. So original one is here at the vertex, lonely. First we reflect, and this reflection go full left. So 1 left, 2 left, 3 left, 4 left, and then 1 down, 2 down here. So negative x plus 4 square minus 2. And this vertex is negative 4, negative 2. Our new vertex. The original one, 0, 0. But now it's negative 4, negative 2. Similarly, upside down, plus 1 means left one. And plus 4 up 4. So original one is here. We reflect, and this reflection goes 1 left, 1, 2, 3, 4 up, and we draw this one. So what is our new vertex? Negative 1, 4. See, opposite of inside and the same as outside. That's how we find our vertex from the vertex form. The next one, upside down, and this time negative 1 means right one. And minus 4, down 4, down 4. So original x squared, we are reflecting, and this reflection goes 1 right, 1 down, 2 down, 3 down, 4 down here, and into the new graph. So what is our new vertex? 1, negative 4. So in the exam again, for the original one, 1 point. For 3 types of reflection, 3 types of transformation, 3 points. So this is 3 points. And then for vertex, 1 point. So 3, 4, 5 points. Question? Now the last question in this section is other way around. The graph is given. Figure out its formula. So we start by the format. Our format is y equals a x minus h square plus k. When you go other way around from graph to the equation, this is the equation you're supposed to start with, not the general form. You have to start with the standard form. Why? Because we have h and k here given to us. So we can replace h and k. And then the only thing we need to know is what is the leading coefficient. So from the 3 unknown, we already can figure out the 2 of them from here. So we just need to solve for this. So let's rewrite. Y equals, we don't know our leading coefficients. And we have, what is our vertex here? What is the x value here? 1, 2, 3, negative 3 and 2. So this h is negative 3. And this k is 2. Right? Let me write h down here. This is our h, this is our k. Sorry, other way around. 2, negative 3. Thank you, thank you. I saw confusing faces. I was like, something is wrong. So inside we have 2, and outside we have negative 3. That means we have y equals a, x minus 2 with a square and minus 3. But we are not done until you find that a. Now to find that a, we can pick any point from the graph and replace x and y with that, so that we have all the variables taken care of besides a. So you can take any point. My favorite point is intercepts. Let's take this point. In this point, what is our x? 0. And what is our y? 1. So from that, y intercept our x is 0 and y is 1. So we have a 0 minus 2 square minus 3. So now there is no more variable besides a. We can easily solve for a. So 1 equals 0 minus 2 is negative 2. And negative 2 means positive 4. So 1 equals, and also we can add the 3 on both sides. So we get 4 equals 4 times a. We can divide both sides by 4 to get the a alone, and we get a equals 1. So that tells us our equation is y equals a is 1, and then we have x minus 2 square, and our k is negative 3. So this is our final equation. See, all these questions, they have y and x, y and x. So we don't replace in the final equation y and x. We leave in y and x, and we replace the leading coefficient, the h and the k. So you'll see this in your exam, probably in the exam, if I have space. But in your homework, definitely you're going to see this. And with this, we are done with 11.56. So left is only one more section, 11.4. And then you'll be done for the semester. Yay! So have a good weekend, everyone. Don't forget to do your homework. 11 point everything besides 4. So 11.1, 2, 3, 5, 6. Do all the homework. Have a good weekend. See you all. See you all again on Tuesday. I had to change the date. I forgot to change it.
Okay, I thought I was doing it.
Yeah. No problem. Thank you for letting me know.